My name's John Spink, for those of you who don't know me, and I have the pleasure of chairing the first session. We'll start off in a couple of minutes. Just for those of you who are wanting IASIS points, you can sign in the reception, and that covers this morning, but you can also sign in for additional points in the workshops this afternoon. So that means you've got to stay until the end if you want the maximum points. Okay, look, I'm chairing the first session, which is really looking at carbon, nitrogen, and establishment methods, some of the key things in terms of the environmental credentials of the sector. And we're going to start off with my colleague Guilia Bondi, who's going to give you a brief update on some of the work she's been doing on soil carbon, particularly in relation to tillage soils over recent years. So over to you, Guilia.
Thanks, John.
And I should say that there'll be, you can put questions up on Slido as we go through these short presentations, and then we'll have about 15 minutes at the end for a general discussion and questions. Okay, Guilia.
Thanks, John, and thanks for having me today. So I would like to start with the question: how can we manage agricultural soil to optimize carbon, considering the targets that the European Commission is setting for all the member states? There is a lot of confusion in relation to the terminology that on carbon. What are carbon stocks and what is carbon sequestration? What it means if my system is acting as a sink or a source of carbon. Soil carbon stocks represent the total amount of carbon that is stored in a specific area, and it really relates to one point in time, just one measure in time. Carbon sequestration instead refers to the change in soil carbon stock over time. So to have an understanding of carbon sequestration, you have to have more than one measure over time of carbon in your soil. A system is acting as a sink of carbon if the CO2 uptake is higher than the CO2 that is released into the atmosphere, and is acting as a source, vice versa, if the CO2 uptake is lower than the CO2 that is released into the atmosphere. Your management help to shift your system from a source to a sink, potentially. So what we are asking ourselves, are we increasing or decreasing the carbon in our system? This is something that we keep studying somehow. And what are the challenges of measuring carbon stock and sequestration potential over the years? One of the challenges definitely taking into account the soil type influence. Different soil can store different amount of carbon. A sandy soil, for example, has a very high uptake, but also the CO2 loss from this system is very high. So the carbon sequestration potential in those soil is quite small. On a clay soil, so a heavier soil, the carbon uptake is similar. However, the carbon loss is lower, so the carbon that stays, that is left over in the system, is actually higher, and the carbon sequestration potential for those soil is higher. On a peat soil, in natural conditions, so not drained, for example, the CO2 uptake is very low, but is also low the carbon losses that we have. So the carbon sequestration potential in natural conditions for those soil is very high. It's very difficult to measure carbon. It's a very small quantity, and it takes a long time to build up. So imagine if you start from a situation which is like that, with a certain amount of carbon in your soil, and then you apply a management change, you start slowly building up carbon till you reach a new equilibrium. Now, it is very important to understand that if you degrade your soil, if you apply some damage to your soil, for example, you can lose your carbon very quickly. So you can go back to scratch one very quick, to the beginning, let's say, very quickly. So the carbon sequester is considered reversible, and it's very easy to lose carbon, and you can do it in very, very short time. This is the Signpost Deep Soil Sampling campaign that I'm leading together with other leaders in Signpost. So we cover in 2023 37 farms where we quantify the carbon that is stored in depth. And then we reach up to 67 farms in 2024, and now we are hoping to cover the whole island in 2025. For each one of these farms, we sample few fields, 4 fields in particular. 10 tillage farms are included in the signpost campaign, covering different soil types and management regimes. And what we did was sampling up to 60 centimeters, so sampling in depth. Now, these are preliminary results for soil carbon stocks in depth across different systems. And as we can see, the carbon in our system ranges from 48 tons of carbon per hectare to 208 tons of carbon per hectare within the 60 centimeters of the profile. Now, this is a very good point for us, especially it's a very good amount of carbon that we have. It's quite high, especially if we compare ourselves with other European countries, in particular with the Mediterranean soils that are ranging between 40 and 80 tons of carbon per hectare. So you can see the difference is quite high. Another important information that we can assume from here is that the tillage farms are overall lower in carbon with respect to the grassland soils, but this difference is not as big as we would expect at the beginning. In fact, tillage farms have an average of carbon within the profile of about 90 tons of carbon per hectare. With respect to the grassland farms that are in average about 110 tons of carbon per hectare. So this difference is not as big as we would expect. 20 to 30% of this carbon is stored below 30 centimeters. So it is extremely important that we go below this depth when sampling. And so initiatives like the post sampling, deep sampling campaign are very welcome. Now, these are data from the tillage farms, ranging from 48 to 140. But as you can see, there is a wide range here, and there are several drivers influencing this range, and soil type is certainly one of them. Light soils, for example, are most likely to be placed in the left side of this graph, closer to the lower rates, while heavier soil or wetter soils are possibly placed on the higher side of this graph. The management helped to shift your amount of carbon in the highest range or in the lowest range within your soil type. Now, preliminary results here. As you can see, for light soils, such as the brown earth, for example, we have more carbon in the topsoil, and the carbon decreases down below in the lower depths. For heavier soil, instead, the situation is a little bit different. We have lower carbon in the topsoil, but you also have quite a lot of carbon in the deeper layer. This is probably due by the higher clay content of this soil that binds the carbon and protect it and prevent it from to be lost into the atmosphere. So very typical in heavier soil. Wet, heavier soil, they have quite a lot of carbon in the topsoil, and this is probably due by the fact that this soil are saturated with water for a longer period of time, and that slows down the decomposition of the organic matter, so you have more organic matter there because it's less lost. But also we have to take into account that we have a very few number of wet soils in tillage farms. So, this data are preliminary, as I said. If we split the soil types in different management systems, this is the scenario that we have. Cultivation method initially doesn't appear to have a big effect on carbon storage in Irish conditions if we compare no-till, min-till, and plough-based system. However, for plough-based system, there is an input of fresh manure that results in higher carbon overall, not just in the topsoil, but also down below, up to 60 centimeters. If you look at the heavier soil, a higher management intensity seems to slightly improve carbon storage at depth with the more carbon in the deeper layer, possibly due by in the plough system, possibly due by the fact that the carbon that is applied in the topsoil is buried down through ploughing in the profile, where, as I said before, is protected, is bound by the smaller soil particles, so protected by the clay. So one of the messages that I want to say here is that potentially there is a soil-specific management that needs to be applied. Take-home messages, overall, the level of carbon are relatively high in tillage farms in Ireland. Different soils have different capacity to store carbon at depth. The soil type is important, but particularly the clay. The clay sets the potential size of the sink, with the heavier soil having the potential to store more carbon in depth. The management, in terms of management, carbon input might be more important than cultivation type in Ireland, and ploughing doesn't seem to be too bad for sequestration potential, as it brings the carbon deeper where it's protected by the clay. Of course, cautions has to be taken into account to keep our structure right. So this work will help to understand where the potential to store carbon is, and potentially in the future generate new revenue stream for carbon farming. And thank you.
Okay, thanks, Julia. I'm sure that'll prompt some questions for the panel discussion after.
Yeah.
So I'll ask Dermot Forristal to come up and tell us about some of the work he's been doing over probably the last 20 years, Dermot, in terms of cultivations and rotations in Knockbeg. And what I should have said at the beginning, if you're wanting to use Slido, there's a code which is NTC in capitals and then 2025. And there are also a couple of polls on there related to this session that we can discuss in the panel later. Dermot, over to you.
Thanks, John. So why was the long-term Knockbeg experiment set up? If you like, there's been interest in non-plough systems since the year 2000, particularly in relation to their impact on work rate, labour and costs, but also their potential impact on soil structure, soil carbon and greenhouse gas emissions. And at the same time, there was uncertainty about their impact on crop performance and the extent of some of the claimed benefits maybe within our climate on those soil structure issues and issues like that. So there's a need for long-term trials because many of these effects cannot be measured in a short period. They're very much long-term effects. So we started looking at plough-based systems, which is deeper tillage followed by secondary cultivation and sowing, systems like those on the slides here, and compared that with shallow min-till systems of establishing crop with a tine stubble cultivator like this, followed by a min-till cultivator like this. For 7 years in the experiment, we had strip till working the system, which is a min-till system. It does cultivate the soil, but cultivates it in strips at the same time as sowing. And we, in latter years, converted that to a direct drill system, which basically places the seed with absolutely minimal disturbance. So those are the systems that we've used in Knockbeg over the years. There have been 3 different phases to the experiments in Knockbeg. The first 7 years, we looked just at plough versus min-till and versus straw incorporation for those years. The next 7 years then, we added in applied nitrogen rates for a PhD that James Brennan did, but it still had the basic treatments in that. Then we changed around a bit, and for the last 9 years, we've had both cultivation systems, 4 different cultivation systems, and rotations combined on the site. And just to say at this point that this is a replicated trial, so we can make statistical inferences from it, and we can see, with certainty whether we are picking up differences or not between the systems. So what we found, and I'm only going to rush through some of these really and focus on 1 or 2 points, but what we found between the work at Knockbeg and some other aligned work was that crop performance is often similar, and particularly with winter wheat, but not necessarily in wetter autumns, and we'll see that in a minute. In terms of machinery, work rates and cost, the non-plough systems generally will have lower costs and higher work rates, but this is related to depth. So if you're shallower, your costs will be lower. If you're working as deep as ploughing, your costs are going to be pretty close to ploughing. Tom Kennedy worked for years and found that over time, and it does take time, there are differences in terms of the soil fauna. So earthworms do increase, but along with that, slugs will increase as well. In terms of greenhouse gas emissions, and Gary Lanigan would have guided some of this work, the overall impact is probably quite small in our climate. Min-till, if you like, or reduced tillage is positive for soil carbon to a small extent, but it can in certain years be negative for nitrous oxide emissions, and its impact on soil carbon overall is probably reasonably small. So in terms of soil microbiology, there was a couple of experiments looked at that during the phase as well. The tillage system can influence the microflora that are there, the bacteria and fungal populations. But whether that has any positive or negative impact, we haven't found from that particular work. Just to look at the yields over time, we had 1 treatment that's carried through while lots of things have changed, one treatment has carried through the 23 or 24 years of trial results there. And the red line that you're looking at there is a plough-based system, right? And this is continuous winter wheat. The blue line is mint till. For most years, they track one another quite well, similar yields. But in 3 seasons and maybe in a 4th season, the mint till is significantly below the plough. And those are the wetter autumns, right? And that is a challenge for the system. A challenge which probably forces farmers into earlier sowing, which brings its own challenges on top of that. So 3, maybe 4 years in 24, there is a difference in favour of ploughing in those years, otherwise quite similar. Just a very simple graph showing our impact on machinery costs, if you like. This is from earlier work that we did, but we updated last year with Jack Jemison during the time of his PhD. So if we took that the machinery costs to establish a crop with a plough-based system have been €200 per hectare, the mint till costs are about 67% of that. That's cultivating to about 120 millimetres. If you're direct drilling, true direct drilling, you're down to 30% of that. So there is saving in that particular component in terms of machinery costs. Following on from Julia, just looking at soil carbon, we measured at 3 points of the experiment. We measured at the start, we measured after 9 years, and again, as part of Jack's PhD, we measured last year. Now, we need to do much more detailed and comprehensive work. The site is available for that, and we will do that in the future on the site. But just to say at this point that while it looked after 8 to 9 years that we were getting a little bit more carbon retention after mint till, particularly in the upper layer of the soil, and it wasn't countered, if you like, by a change deeper at that time. When we looked again last year, we see virtually no change. Same levels of soil carbon in both systems. So what we're saying here is that really the effects on soil carbon are probably quite small over time, but we do need to do more work on this particular area. Just to move on quickly, we've incorporated cultivations and rotations. We have a 5-course rotation running, winter oilseed rape, followed by winter wheat, followed by winter oats, another winter wheat and winter barley. And we're comparing that with continuous wheat. And we're doing all of that with 4 establishment systems: plough, shallow plough, mint till and strip till, okay? And if you look at that, and you look at red being plough, orange being shallow plough, blue being mint till, and green being strip till, over all crops of the rotation over all years, there is a slight disadvantage to the strip till, just about reaching significance across all crops over those years. The other systems, no difference between them. But remember, this is on our site, and it's very much associated with management and site and things like weed control. But just to show on this slide, these are the different crops: oilseed rape, winter barley, winter oats, and winter wheat. And you can see that in the winter barley, that difference was probably at its greatest. And we feel in this, on our site, sterile brome was probably contributing to that. The more open crop of strip till early in the season, probably allowing the sterile brome to do well. In contrast, the winter oats, no difference at all in performance with the strip till with winter oats. So it is crop and probably management dependent in terms of the performance of the systems. Most recent elements of the work in terms of crop establishment, Jack Jemison has just completed a PhD where he's used the control trials at Knockbeg and first wheats, compared those to on-farm studies, which I'll show you one slide about in a minute, and he's coupled that with some other surveys as well. So that's Jack's PhD. There's a project called Evolvent, which is mainly a grass weed project, but there is an important carbon modelling task which has just started this year, and we're actually getting soil respiration data this past autumn from that site to feed into that particular task there, and that should help us in that area. Climate cropping is another EU project, which we basically, this site, along with other long-term sites across Europe, are feeding in to see can they model the effects of changes in soil management on particularly soil health and soil quality. So that's some of the recent work that's there. Just to go to some of Jack's work, and you might have seen some of this before, and Jack will present it again in various stages, but in Knockbeg, he's been looking at plough, mint till, and at this stage we had changed to the direct drilling. And the green bar is the direct drilling bar, and you can see in the 3 years that we looked, and it doesn't include 24, which will be a different story, in the 3 years that we looked, direct drilling held up reasonably well. Slight advantage to ploughing in 2022, otherwise no difference between the systems. But Jack also looked at these systems on farms, okay, and we had 7 farms with each tillage type, followed first wheats for 3 years on each of those farms. And you can see the plough and mint till were very similar, but on the farms, the direct drill, in contrast to what we found in the control trial, the direct drill performed slightly poorer. So Jack kind of looked into that and basically found that there were other management differences which may have been associated with that. In other words, the farmers, probably anticipating lower yields, were using less nitrogen and a little less fungicide on those farms as well. So it just shows you the importance of having the controlled trial, if you like, to answer some of the questions that might be out there. So in general, coming towards the end, I suppose generally min-till systems, they have the potential to be high output systems with lower costs, and they do have some soil benefits, right? But these benefits sometimes can be overestimated. In terms of soil carbon, greenhouse gas emissions, the differences are probably small in our climate, but they may still be important. But things like strong cooperation and covering cropping may contribute more, okay? Definitely, the systems are, in terms of the crop establishment, can be challenged by wet autumns and later springs. And that's linked, I suppose, to weeds and grass weeds in particular. And grass weeds are a threat. Grass weeds are favoured by non-inversion, by early sowing, and by mild climates. And relying on herbicides at the current time with loss of registration of products and resistance issues is not going to solve the problem. So we need to have every cultural tool in the toolbox, right? And the tillage system themselves are part of those. We need to be able to use stale seedbeds. We need to be able to use ploughing as well where it's needed. So that's what I mean by every tool being available. And we need to use crop rotation. And this is a very difficult area that we need to work towards in the future. So we need flexibility within our systems. And we don't need to have really rigid systems. And there isn't probably a justification for those rigid systems anyhow. So we need to be flexible. So future challenges, there's lots to be done. Like what we're trying to do, I suppose, is produce sustainable production systems against the background of reduced pesticides and fertilizers in the future and increased environmental requirements. That's the challenge that's out there. Rotations and establishment are important in that context, and we need to develop or have robust climate-specific data. We need something that's suitable for our climate. We need to look in particular at their impact on nutrient cycling, carbon loss and sequestration, soil structure, weeds, and so on, and how this interacts with agronomy in terms of disease control, weed control, pests, and even down to economics. To do that, long-term sites with a cropping history are certainly useful, I'd say essential. The Knox Beg site is unique, but a larger rotation base is probably needed for some of the work that's needed towards the future. We certainly need a multidisciplinary approach. It's not just looking at crop performance. We need to look particularly at the soils and indeed the environment generally. So we need to create and use these long-term sites carefully. I'll leave it at that, John.
Okay, thanks, Dermot. So we'll move swiftly on because Dermot took far too long. To Bridget Lynch, who's going to give us an update on some of the work that's been done in the agricultural catchments programme on cover cropping and also the water EIP measure. Bridget, over to you.
Okay, thank you, and thank you for having me. Okay, so we're all familiar with the headlines from the EPA reports. It was about 60% of our river sites nationally have high to good status for nitrate concentrations, but about 40% have unsatisfactory nitrate concentrations. In the southeast, we have high levels of agricultural land use, and that coupled with our free draining soils and lower effective rainfall means that we have higher concentrations of nitrate, particularly in the southeast region of the country. The Agricultural Catchments Programme was established in 2008 with the remit of evaluating the implementation of the Nitrates Action Plan through the GAP regulations. The Castle-Dockrell catchment within the Agricultural Catchments Programme is our arable dominant catchment, and it has an average nitrogen concentration over the entire monitoring period of 6.98 milligrams of nitrate nitrogen, and that's too high. So we know from Teagasc research and internationally that overwinter cover crops are effective at reducing nitrate leaching. Farmers in the catchment have been sowing cover crops through the agri-environmental schemes, but also voluntary. So outside financial incentives, there are some areas being sown. And the cover crops are a measure within the Farming for Water EIP book of measures. So it's measure 6 within that book of measures. And that was available in 2024 for farmers to apply for. In the Agricultural Catchments Programme, we track nutrients along the nutrient transfer continuum. So from source on the farms, through the landscape, and we look at the impact of those nutrients, so largely nitrogen, phosphorus, and sediment in the river networks that we're monitoring. So we've got various different types of measurements throughout the landscape. So we have soil fertility testing across the farms on a paddock scale every 4 years. We've got local weather stations, so we can track the weather influence on nutrient loss. We've got pit maps. We've got groundwater wells that look at the nutrient concentration at different levels in groundwater. And then at the outlet of the catchment, so where the water leaves those small catchments, we've got high resolution monitoring every 10 minutes of nitrogen, phosphorus, and other parameters. And then twice per year, we do ecological sampling of the rivers to see what the ecological status of it is. So when we map out all this on our Castledockrell catchment, so this is the catchment here. This is the catchment boundary, so we know that all of the rainfall, so we get about 1,050 millimetres of rainfall in Castledockrell annually. All of that falls within that catchment boundary, and it exits the outlet or it's lost through evapotranspiration. So our outlet is situated here. We take monthly samples throughout the river networks that feed into that. But we've also got groundwater wells that are in a transect in the north of the catchment and also in the south of the catchment. So I'm just pointing these out because I'm going to show you some data from those shortly. So these are positioned in the upper, mid, and near stream slope on both the north and the south of the catchment, so we can track the groundwater at different levels as it comes in from both sides of the catchment. And there are several land parcels that feed into those or that overlay them as well. So this is the cover crop area that has been sown through gloss and acres over the last 3 years. So we've seen 120 hectares within the catchment boundary sown with cover crops through the agri-environmental schemes. In the year just gone by, farmers were able to apply for the Farming for Water EIP funding to increase their area of cover crop sown to a max of 20 hectares, in addition to what they had submitted in acres. So we've had an 87% increase within the catchment boundary of cover crops sown over the year gone past. So, a really positive increase in the area of cover crops sown. And the funding is available through the Water EIP for the next 3 years up to the end of 2027. So we've got momentum now to increase the cover crop and sustain that over the next number of years. When we look at, I suppose, the efficacy of cover crops in the Castledockrell catchment, this is a lysimeter study that was conducted within the catchment where we looked at sown cover crops, so leafy turnip and forage rape, compared to a treatment that was let fallow after spring barley was harvested and natural regeneration to occur during the drainage period. So a significant increase in crop nitrogen uptake from the sown cover crop compared to the control. And we had a significant reduction in nitrate leaching from the sown cover crop compared to the control in that lysimeter study, which looks at drainage water up to 1 metre. This is going back to our north and south groundwater wells that I pointed out on the map earlier on. On the y-axis, we've got nitrate nitrogen, and on the x-axis, we have the years of monitoring in the programme. So the north well is the green line, and the blue line is the south well. So you can see in 2020, we started to observe that the north well transect, on average, was starting to become lower than our southern well transect, which remained relatively stable over that period. So the land use in those two transects in our south well, this is in a rotation of spring barley and winter barley, with the spring barley followed by a cover crop and the winter barley areas left fallow over the drainage period. And in our north well transect, we've seen spring barley which was followed by a cover crop and a grassland lay that's in a cutting system there since 2020. So overall, where we're seeing more coverage over the winter, over the drainage period, and less spare soil over that period, that we seem to be getting a reduction in nitrogen in the groundwater wells that we're monitoring. But I suppose we need to sustain the cover crop area sown over a number of years in order to have an impact at the catchment scale. So what I'm showing you here is the Castle-Dockrell catchment annual nitrate concentration over the years. So we've a relatively stable nitrogen concentration right throughout the year and between years in Castle-Dockrell. So there's this large pool of nitrogen essentially in the deeper aquifers that's just this constant supply of nitrogen. If we compare that to some of our grassland catchments, you can see that there's far larger peaks and troughs throughout the seasons within year in the grassland catchments. So where we're seeing a positive effect in the drainage water and in the groundwell monitoring of cover crops, we need to sustain that over a number of years in order to deplete this pool of nitrogen that's in the deeper aquifer, and where we should see an impact on a catchment scale and our larger river networks over a period of time. So sown cover crops are effective at reducing nitrate loss, and it's our number one tool, I guess, for arable catchments. Early sown is important. So in 2024, as you all know, cover crops went in later. When we sampled those in December, we sampled a number of those across the catchment. Above ground biomass was about 500 kilos of dry matter per hectare, towards we would observe near 1,000 kilos of dry matter per hectare above ground biomass in previous years. So hopefully we can get them in earlier if the weather plays ball over the next couple of years. Species inclusion is important, so just going back to if you've got brassicas in your rotation, we've had an increase in area sown, and that funding through the EIP is available up to the end of 2027. When we survey farmers, they view catch crops very positively, and in fact they value, I suppose, the soil health and structure aspect of them in addition to the benefits that they have for water quality. Discussion groups, I suppose, for those from industry that are in the audience, and for ourselves, farmers value, discussion groups, demonstrations and farm walks for learning more about cover crops. And cross-industry collaboration is key as well. So advisory, merchants, seed companies, with all their initiatives and messages around cover crops, it's important that they work together, and that's, I suppose, feedback from the farmers that we've surveyed in recent years. Okay, and I'd just like to thank those in the programme that helped me pull the information together for today's talk. So thank you.
Thanks, Bridget. So Bridget, if you'd like to join me over here on the panel, and Dermot and Julia also join me, and Richie Hackett's going to join us to answer any questions you might have about cover crop production. And just while they're making their way up, apparently a DCI card was found in the car park, and it's at reception if whoever's lost it would like to collect it, and if not, I'll fill my car up on the way home. Okay? So put your questions onto Slido. Say there's also polls on Slido, and there's the QR code if you need it for Slido. We'll also have a couple of roving mics if anyone would like to ask a question in the room. But if you are asking a question in the room, I'd ask that you keep it quite short, because we only have about 10 minutes now until the end of the session. Sorry?
Can you get it on the screen?
But we can't.
Can that be put up on the screen? Or?
On the screen.
Or here.
So the first question on the... Show me that. We'll do it the old-fashioned way. The first question was, is carbon sequestration important to you? And 84% have answered yes, and 16% have answered no. And there's another poll going up now to ask you what actions you think would be important or you'd be interested in terms of improving soil carbon. So there's a question here which I guess is aimed at you, Dermot. instead of no-till versus plough, should we not be researching conservation ag, no-till and cover crop and residue retention, I guess, versus ploughing?
Yeah, I think it's a good question. Because as I've been kind of hinting to, there's an awful lot of elements in terms of if you're trying to improve soil quality, if you're trying to retain soil carbon in there. So yes, you could say that we looked at one aspect, which was the tillage system. And what I was saying really is that the tillage system is only one aspect. It might be quite small in terms of our climate, and yeah, you've heard what I've said about that. So yes, I'd agree with that, but I think we need to look at the different components. We need to look at what's actually working in the Irish climate. We need to look at the cover crop work that both Richie and Bridget will work on, so, straw incorporation and so on. So it is very much about a whole system approach, but a system approach that's suitable for our conditions, that allows us to do all of this while having good crops and also not running into long-term weed control problems, weed control situations.
Okay, thanks, Dermot. There's a good few questions coming in, so we'll move on. There's one here for you, Julia. Is there a maximum amount of carbon that can be stored in the soil? If yes, as Irish soils are already rich in carbon, does that mean it'll be harder to sequester carbon?
So yes, so there is a maximum of carbon that can be sequestered. The sink is not infinite. This limit is set by the soil type, let's say. So in some soil types, this chance, as I said, it's higher than in other soil types. And then I don't see the other part of the Irish soils are
high in carbon.
High in carbon. Yes, they are high in carbon, but this doesn't mean that, so the work in that sense is more maintenance rather than improving carbon. So we'll have to, I suppose, push towards our highest limits and then try to preserve our soils the way they are. That's the important thing. Yeah, in a tillage scenario, there is the chance to improve carbon, I'd say, still.
Okay, one I think I might pass on to you, Richie. Are winter crops good at N sequestration, and how would they compare to cover crops?
Yeah, well, winter crops obviously do take up nitrogen, but it's relatively limited. So any work I've ever done, you know, if you measure the nitrogen in a winter crop in late February, early March, 20 kilos, maybe 30 kilos in a really good crop per hectare. Whereas if you take a cover crop, you know, Bridget showed values of about 30, 40 kilos per hectare, and any work I've done, we've made measurements up to 80, 90 kilos per hectare where there's good growth. So you're getting a lot more growth with the cover crop compared to the winter crop, assuming the cover crop is sown, you know, in August versus the middle of September or something like that. So I would say cover crops are better than normally, cover crops sown at an optimum date are better than winter crops sown at an optimum date.
There's a question at the bottom there, which is to you, Bridget, but I think Richie might also be able to contribute to this because he's done some work in the past. Is the retained nitrogen in the cover crops becoming available to the spring crop? And should people be reducing N applications to malting barley crops?
Yep, so I suppose where there isn't a legume contained in the cover crop mixture, I think the benefit to the following crops is limited from the work that Richie has done. But if there is a legume contained in the cover crops, and lots of the commercial mixes that we see now have a legume or two in them, there is potential for that to remain there and become available for the following crop.
So yeah, that sort of sums it up. You need to know how much nitrogen is in the cover crop. If there's not much nitrogen in the cover crop, you're not going to get much back into the crop. If there is a lot of nitrogen into the cover crop, it gets a bit more difficult. You have to know how quickly that's going to be released. And if it is going to be released, then you need to reduce your fertilizer nitrogen. But predicting that release is really, really tricky.
Okay, thank you. I should also add that Bridget and Julia and Dermot will be on panels this afternoon in the workshops. And whilst I don't think Richie's listed on a panel, I'm sure he'll answer any questions during the afternoon in relation to cover crops. So Dermot, you were showing yield differences in the different cropping systems. Is there a margin per hectare difference in the...
Yeah, Very good question, yeah, and Jack Jemison has actually done that work as part of his PhD. He has a paper submitted on it, and it would show, yes, that on the farms, now it was only on the farms actually we got the yield difference, like if you like on our knockbeg work we didn't, but on the farms where they got the yield difference, yes, it's fair to say that the cost savings that were there did counter the yield loss that was there. So there was no significant difference between the margins across the systems on that study of 7 of each type.
Okay. Thanks, Dermot. And there's one here at the bottom. I don't know if we know the answer to this, but I'd like to know the answer if we do. So, do we know if cover crops enhance soil biodiversity as well as preventing N leaching?
Well, I suppose biodiversity is a very broad term, but we did some work that showed that some cover crops can increase earthworm numbers, which I think you might call a biodiversity, but there's also international work that would show that different cover crops can enhance the soil microbiome, to use the modern word, in terms of, you know, stimulating different groups of bacteria and fungi and that sort of thing.
Yeah, look, there's co-benefits of cover crops. You know, they're good for nitrate leaching, as we discussed already. They improve soil fertility, soil structure, and improve soil health, which leans into Julia's work as well, which should increase soil biodiversity, as Richie said already.
Okay, and I'm going to keep picking on the two of you, I'm afraid. So which species of cover crops are best for sequestering carbon, and how many years would you need to grow them to have an effect? That's probably a question for, I don't know, Richie, Julia, Bridget?
I think it goes back to the fundamentals of photosynthesis. So the more leaf area you have, the more carbon that you're going to sequester. So higher yielding crops or faster establishing species are going to sequester more carbon. On how long does it take to have an effect, it's going to take time over a number of years of continuous cover cropping in order to make an impact on the soil organic carbon, which Julia might pick up on.
So deep rooting systems as well are important because you add root exudates into the soil in the deeper layer, which we have seen to be really important to keep the carbon protected. So that might be also.
Okay. Do you have anything to add, Richie, or is it well covered?
Yeah, pretty. I mean, the more you grow, the more you put into the soil, the more bigger effect. But I guess it also depends on the quality of what you put into the soil.
Yeah.
So something with a high carbon to nitrogen ratio that's approaching, say, straw, which is a very high carbon to nitrogen ratio, is going to add more to the carbon sequestration than something that's young and leafy that's going to break down very quickly and release the nitrogen very quickly.
Okay, and another one, I will try and get in two more quickly before we run out of time. Most research would normally show that ploughing would be bad for carbon sequestration. Do you have interaction between soil type and practices in your data? Well, Dermot.
Yeah, I think, well, Julia can answer that. I think she did have an interaction. You showed light versus heavy with that. But just to say before Julia goes in there that I would say, first of all, it's tillage rather than ploughing, you know, because it's sometimes we think it's ploughing in particular. But yes, if you are cultivating to a depth, you are releasing a little bit of carbon during the cultivation action, and you're also by having smaller aggregates maybe exposing more surface area. So there is you know, a potential reduction in carbon. I think most people would accept that. I suppose what I was saying, and I think what some of Julia's work would show indirectly, is that that's probably quite small in our climate, or relatively small. But you had something on the interaction in yours, I think.
No, I don't. I don't really have to add that.
I mean, from my experience, well, from my understanding, it's probably more to do with an interaction with climate.
Yeah.
And if you have a hot, dry climate and you disturb the soil, you'll burn off more carbon, a bit like the data Julia had from the Mediterranean showing much lower soil carbons. Yeah. And if you happen to live in a cold, wet country like Ireland, the effect of cultivation is less.
Even this year, John, I mentioned that we're doing some soil respiration studies as part of work with UCD. Now, it's very early stages, but what was very interesting that on the min-till establishment system, where we cultivated for stale seabed early, we were getting some emissions during that phase because the temperatures were warm that you didn't get with the plough system because the plough cultivation started later. So it's very climate related.
It's not simple, I think, is the answer.
No.
Yeah.
One answer.
Like
So one final question before we run out of time. 20 to 30% of the carbon is below 30 centimetres. If tested in the 60 to 90 centimetre zone, how much more carbon might you expect to find? Julia, I think that one's definitely... targeting you.
So again, these percentages that we show are highly dependent from soil type and the management that has been applied. And specifically, the soil type makes the difference. I'm not sure about the percentage, but yeah, it can be another maybe 10, 20% or something like that if I would have to make a guess. Yeah, like it's now widely used, this depth, to assess carbon stocks at a global level anyway, up to 60 centimeters. So we might be sure that the majority of the carbon is situated there.
Okay, thanks, Julia. I think we'll stop there with questions. There was a further poll about how people are supporting carbon sequestration. There were a range of options. You'll have seen them. A third of people said all of the options they were using to support carbon sequestration. A quarter using straw incorporation and cover cropping. 14% just straw incorporation. Another 14% using farmyard manure and organic manures. And 8% just cover cropping, and then 1% for minimum tillage. Don't forget that there was a third of people doing all of the above at the top. And I don't know whether it's just not appeared on the screen, but there was no one said it's not important to me. Okay, look, we're out of time, so I'd like to thank you for your questions and your interest. To remind you that in the workshops this afternoon, there'll be opportunities to discuss all of these things again. I'd also like to thank the panel, Bridget, Julia, Richie, and in particular Dermot, because Dermot's retiring later on this year, so this is the last time we will be able to force him to perform at the National Tillage Conference. So thank you all. I should say he's retiring early.